So I'm Alex Porter. I'm the CEO of ModTech Labs, and I'm here today to share with you how the new reality of media is shifting. We are going to be enabled with a lot of really amazing tech coming up now that 5G is really being deployed widely, and 4D or volumetric video is becoming more ubiquitous. So I'm a serial entrepreneur. This is my third major tech startup. We have actually founded Underwriter Studios, in which we were doing XR for businesses. Volumation was an early iteration of what is now ModTech Labs that was focused specifically on volumetric video. And now we've really expanded to include everything from scans to photogrammetry and beyond. And really, we're looking at the big, broad industry for imagery. So I graduated with a BS in interior design and a minor in construction technology. And what that really helps with, as far as my career is now, is being able to really visualize and understand that physical space. And I've been able to translate that into the digital medium. So it's a really fun intersection that I never anticipated as I was learning in school. Over the last few years, we've worked across different verticals. We've worked in entertainment, we've worked in media, we've worked in medical, and corporate, among others. And our focus has really always been creating tools that are the back end, the functionality of this technology. So in lieu of just doing, brand engagements, in lieu of just doing gaming, we're really focusing on things that have more of a longevity and can be put into place to be used long term. We are a venture-backed startup. We have been invested in by Sputnik ATX and Quansight Futures, and we are based in Austin, Texas. For the last 3 years, we've actually been awarded, myself and my CTO have been awarded top innovator awards by Intel for our work with them. And last year, we also won an innovation award from the city of Austin for our work in immersive media. So the core of ModTech Labs really boils down to a few key points. We are 98% faster processing. We use distributed processing that enables us to work significantly faster, and things aren't stuck waiting in queue. They aren't waiting in line for the next process in ABC order. They're just going to the next available machine. And so many of our processes are 98% faster, which is crazy. Sometimes a little more even. We've automated systems, which means that really the machines are doing the work. This is not a person behind the curtain pressing buttons and manipulating things. We are able to really just push this through and have the machines do all of these things, all these menial sort of tasks that don't need to be touched by a human. And that really helps create more opportunity across work pipelines. We have a universal input and output, which means that we can intake any kind of imagery data, as I mentioned, photogrammetry, volumetric video scans, etc. And we really think that the important part of that is, any sort of platform, any sort of software as a service out there really needs to be flexible and have the ability to ebb and flow with the types of data that are being worked with. And so that's why we built this very open-ended. Our output is open file types, so FBX, OBJ, your standard sort of types, and we're always investigating sort of what the new standards are, what they're becoming, and how we can enable those as well easily. And last but not least, all of our processing happens on a secure private cloud. So we actually own our own machines. All of our data transfer is encrypted, and everything is on our own personal machines between us and the client. So there's a lot of really cool functionality that we built in, thinking about the industries that we're working with. VFX, games, movies, media. They really want to make sure that their data is secure, and we have created this with that in mind. So part of the VFX process is really understanding the massive flow. There are many parts to this, and then you start with pre-visualization, really understanding sort of where you're going, your storyboarding, what you're looking at, how you're gonna set up different sets and things like that, your production, really planning the timing, all of that good stuff. The shoot itself, of course, famous people on camera. The scene prep, motion tracking, key, and color correction. A lot of that has to do with whether you're shooting on a green screen, whether you're using motion capture suits, etc. There are a lot of things to take into account there. Effects and simulation, water droplets, fire, etc. Texturing, skin looks like skin, wall looks like a wall. Lighting, there are a lot of different environments, whether it's a game engine or elsewhere, that you want to make sure are effectively lit, because that helps with the level of realism. And compositing, of course, getting all of those things together, combining them into one scene, and then color grading so that the entire scene looks like it belongs in the bigger picture, the bigger movie or game, if you will. And really functionally, this means that there are thousands of people across a pipeline that are touching this. And each one of these individual sections has its own sets of software, has its own sets of specialized people that are running these things. And what we're looking to do is use that automation to take away a lot of that sort of menial touch base points of getting the file from point A to point B, by really allowing one system to intake that imagery data, process it through the different things throughout the pipeline, including previs, scene prep, effects and simulation, and texturing that we've currently automated with AI, and handing that back for that last final human touch. The staggering fact is that 25% of movies now typically are really they're VFX. That budget is dedicated to VFX. So if your typical movie, Avengers style, is looking at $150 million budget, then it's $40 million nearly that's spent on VFX. Why 5G for capture? Everyone, is super curious about what the function is of 5G and how it matters in regard to capture. And the way that we like to think about it is, with these massive amounts of data transfer, how are you enabling that? You are enabling that with good network, right? You can't move data from point A to point B without network. And so, Wi-Fi itself is not great for this. And we really find ourselves doing a lot of hardwiring to make sure that we can get the data connectivity that we need to move these massive data packages. So I want to talk a little bit about use cases. So use cases are really sort of the way that you frame it, right? How does this matter? Why does this matter to me? What can I do with this information? A good use case here is St. Elmo's Studio. And we're gonna watch a little, oh, that is not the right video. That's okay. So the good use case here, this is actually a local studio to us. They're partners of ours. And the function here is that we actually set up this rig. It's 104 cameras, webcams, and 26 upward computers, small form factor computers, and a massive amount of networking and power, as you can see. And ultimately, there are a lot of ways to use this, right? First of all, you can use this for full body volumetric capture. You can use this in ways, the bust only. You can actually make the rig a lot smaller. And the data footprint itself gets smaller when the rig gets smaller. And so there's a lot of cool, fun ways to create opportunity with that realism that you get from volumetric video. Those macro and micro expressions from the face are really the highest fidelity point for volumetric video. And so we've experimented with lots of different ways. A better use case, this is the head rig that I mentioned. So in this one, we were hosting the ATXR hackathon in conjunction with Intel and Walmart Technologies. We had sponsors from Vive, through Intel, et cetera. And the focus here was to actually capture not only with the head rig, but we actually also had the folks in the room capture with their cell phones. And so we were able to combine the data and imagery from the head array here that you can see with those sort of crowdsourced images. Oh, and now something's talking. Oh, hang on. It went to YouTube. No YouTube. Go away. That's half the fun of this, right? All right. Present again. All right. So we were able to take the data from the head array here and actually combine it with the data from the cell phones. So we had crowdsourced imagery to actually fill out some of the missing data because this was a smaller rig, and it gives you lots of different vantage points. So this is a very portable rig. This particular one, I think, was 15, 20 cameras. And so it's a lot easier to get from one place to another. And what you can do is you can combine a volumetrically captured head with a photogrammetrically captured body. And then you can actually overlay some motion capture, you can rig the body, and there's a lot of cool functionality that you can even do there. And then this was actually a great, really fun shoot actually. Physical VFX makeup. So these folks are actually also Austin based. And the goal here was to do some experimentation around capturing physical VFX. And you can see here, this gentleman, that his makeup didn't end up turning out. This is one of those best practices moments where it was too shiny. However, this lovely lady, this is actually a photo of the subject, and this is her volumetric head. So you can see there's a lot of interesting ways to actually create these assets using, physical effects, using digital effects, and making them functional for any kind of pipeline, any kind of implementation. In this particular case, the goal was actually to use this for television. They do a lot, this Hogfly Studios does a lot for The Walking Dead, Fear of the Walking Dead, and many other shows. They're shot in Austin and elsewhere. And the question always is, what are the capabilities of these systems and how can we implement them and create more use cases? So 5G for transfer, really it's all about getting away from the cabling, getting away from the cords, getting away from the Wi-Fi, necessity, getting away from, the dependency on being tethered to something. And the more that we can create these opportunities for data transfer, the more we can jump over hurdles like what we faced at St. Elmo's. They don't have the best consistent internet. They're actually in an industrial complex. The building itself is it's built as a soundstage, so it's actually got extra insulation. It's got extra soundproofing. So those also create issues with just signaling. And the way that you really want to use this on a shoot is you want to be able to do those sort of instantaneous dailies. You want to be able to understand that the thing that you're capturing is going to come out in the fidelity that you want to see it in. And so you want to check that lighting consistency. You want to check the sheen and the depth. You want to make sure that the costume is picking up properly. You want to make sure that the timing consistency is correct and you're not getting some weird latency between the capture of different cameras. And honestly, when you're working with this many cameras, hopefully you have them all set up properly and that no one has messed with settings on them. But, there are a few things you want to make sure that there are not, the fisheye lenses, that's not as much of a thing that changes per se. But really, it's fisheye lenses. There's some other stuff about just the general settings to make sure that the functionality overall is effective. And so being able to test on site and calibrate in place means that these shoots will actually be a lot more functional long term. So the head rig, I've mentioned a few things about this. I just think I think it's a fascinating use case because we've talked to many companies about this, including some big known names. How can we get the facial fidelity that we need without a facial mocap rig? And facial mocap rigs, you're looking at 100 and some odd points on the face. That is never going to give you the realism of a human face. We have these macro and micro expressions. We have flushing. We have all kinds of really interesting and very minute things that happen with our face that help us detect, oh, that's another human. And when those things are missing from your CG elements, from your facial mocap, from your other applications of trying to make virtual humans, people detect that, right? That's the uncanny valley. It gets a little weird, you get a little creeped out. And that's one of the best ways to use volumetric video. The gross motor movement of the body, really, volumetrics are not the best for that yet. They're good, they're okay, and especially if you have a dedicated stage, which I think is really kind of an older model now, especially in the times that we're in. It's a lot harder to get into a stage. It's a lot harder to travel to and from the stages themselves. And so what we're trying to do is really open up the capability of people to capture themselves. So a production studio that's already doing photogrammetry, this enables them to do a lot more that they haven't been able to do before. So it's portable, right? The optimization for mobile transfer means really just, you know, you can pack it in a couple of, you know, hard cases and you're good to go. We actually have fit the entire large rig into a Honda Civic. So, I mean, it's not a very large car, and it's a pretty solid amount of equipment, but it's not unreasonable. So it's much more portable than, you know, other styles of rigs. And the full body camera array here is 108 cameras for a minute of time. It's 108 gigabytes of data, right? So it's massive, right? It's a massive digital footprint. And you know, 5G, the tracking of data to be able to even just view it on site, much less actually transfer it. You know, in our early days, we were definitely looking at and talking to clients about sending hard drives. They were sending us physical hard drives because the transferability of these massive data sets was pretty much nil. We've definitely solved for that now. We have a lot of great ways to get around that. But if you can combine the head, the volumetric head, with the photogrammetric body, then you're looking at 20 gigabytes per head. Significantly smaller. And you get that wonderful face fidelity. And you can see here, this was actually created with a webcam rig. So we have all of our demos some of them are on our site and modtechlabs.com, and many of them are also on our Sketchfab, sketchfab.com/modtechlabs. And so you're welcome to go in and check them out and play around with them. Our YouTube also has a lot of demos in reference to sort of our new product offerings and other opportunities there. So our head replacement with motion capture, you know, we haven't touched on this too much, but this allows us to drive, you know, the facial animation and the body, you know, animations or motion capture separately, right? And this is also a wonderful use case for animation itself. So if you want to do an animated character overlay, you can get a lot of that human attenuation, tone, facial movement by tracking it to something with millions of data points, like this head on the bottom left. That's a wonderful thing. So we are testing this and seeing how we can easily implement this into pipelines. You can see here, there are some techniques that we're doing in regard to optimization that are super important. Not only that, you know, for that data footprint to minimize the size, but also just the fidelity of your asset. You really, you know, you can see that the before and after here obviously are quite starkly different. This very, very messy mesh and this, you know, messy texture space. And ultimately, you know, you get less fidelity from the end character. And so we have created these in order to solve for a lot of the intrinsic issues with these massive data sets. You want to be able not only to optimize them for fidelity, but you want to be able to optimize them for the right size and playback for the device that you're using them on. So, you know, we've seen a lot of use cases for volumetric in VR or XR, if you will. And we've seen them, you know, sort of touching into games, touching into movies. And the reality is, at one point, this is likely to be the way to capture. And for now, we are, you know, we're ready to do that. We're ready to help people set up their camera arrays with their existing equipment. We've already worked with several studios to do that. We've converted bullet time arrays. We've converted other DSLR rigs to capture for volumetric. And we think that there's a wonderful opportunity, you know, for anyone that's already in the capture space to add this to their repertoire, to their offerings, and really expand this. And I think the thing that was really missing is, number one, an understanding of how to capture properly for volumetrics, which we have a capture guide available. We have lots of knowledge about this because we have tested and iterated on it ourselves. And we have a processing solution that is ready to go. So last but not least, temporal preservation. So this is, you know, part of that optimization. It's one of the offerings. And the goal here is to really maintain that same texture space and mesh space over time. So for each frame, it is the same, which minimizes that data footprint, but maximizes that fidelity, as you can see here. It's just one of the things that we have created to really make this technology more accessible and more functional. So obviously, asset build out, we talked about real world objects. The goal here, with photogrammetry is still objects. That's really sort of, the prime use and function. And so there's a lot of opportunities here, in the asset build out, virtual production, obviously, there are many ways to capture, a person's body, A-frame, A-pose, T-pose, and then you're putting those in and creating more opportunity by rigging them, by adding mocap, by doing all kinds of other things to add in more of that realistic movement. That's typically the case here. Scene build out, there are a ton of folks out there using, drone photography. There are a ton of folks out there using, point and click cameras to go and take scenes. There is a massive amount of interesting ways to use this in regard to pre-visualization, all the way through to actual, finalization and implementation of environments inside of, major motion pictures, VR, you name it. And then character rigging, of course, I mentioned that a little bit, but FACS, your facial animation systems, you are looking at, how you actually take that realism from the human face. And this is this is the most common way to do this now. You're also, folks are getting into, other techniques as well, but there's a massive amount of function here that has been utilized across industries for realism. Have anything to add, Tim?
Of course. I always have things to add. I would definitely say one of the biggest things to remember while you're doing photogrammetry and you're using these use cases is that there are ways to go ahead and delight any of your assets. So a lot of people get themselves stuck, especially when they're getting new into photogrammetry and then they take an asset directly in. Unity has a delighter, a lot of other tools can do that based off of normal map. And the other thing is, if you haven't done a whole bunch of work inside of game engines, a lot of the technology that you're going to be walking into with photogrammetry, especially as you're going into real-time production, really does lend itself towards spending some more time looking at what video game paradigms are. We actually did a talk earlier on this. I gave two talks yesterday, one of them on how to do video game paradigms as far as real-time production and what you would want to go ahead and do and use and asset production and pipeline, everything like that. And then I gave another talk in the beginning of the day that was specifically on how to do optimization. Like, what do you want to spend your time on and your energy on, and where do you want to go ahead and put your efforts into while you're doing this, because you're walking at this point in time away from what is traditional waterfall style production, and you're going into more of either an agile methodology or into a secular. If you're not familiar with agile, is the idea that I could shoot today and I could do my assets tomorrow, which is just insane. But you can also shoot today, have the assets, and have a background version of it that's low quality, and then you can have a higher quality one so it can be showcased. So it also doesn't have to happen where it's entirely separated. If you look at what they did with The Mandalorian, where they said more than 50% of the shots were actually done in camera. Now, I suspect they, of course, did things like sweetening it at the end, with some color correct and maybe some grading, blah, blah, blah. But they said what they did was dome, use the dome for lighting, and then they had a background with a green screen, and then they would go ahead and they do the capture, and then the green screen was taken away with advanced machine learning algorithms, and then they were able to go ahead and add back in these assets. So they could do all these changes and everything all on set. And that can happen here. It's a play. It's no longer this goes to this and this goes to this, and then it goes downstream, and then you end up rendering things and it comes out. How does it come out? Who knows? It can all interplay, and you can do all of these things now, tomorrow, yesterday, all at the same time. So I think that's kind of the biggest thing to remember here, and the reason why photogrammetry is such a big thing. You could even have a lot of fun with it and be the world's biggest supervillain and take scans of absolutely every major artifact in the world and have them around you, and they would look real because they were. So.
Much less mystery. Absolutely.
No, I believe that these people would be full of intrigue and mystery. I don't believe we're losing any of that here.
All right. So scanning, again, we're capturing spatial data, physical objects, and environments. It's really similar, but there are some other ways to capture it versus just, sort of standard cameras, if you will. So structured light, LiDAR, and lots of other miscellaneous scanners out there. And again, there are a lot of benefits to, this particular type, especially in regard to environments. As we see there's a drone, right? Drones can use photogrammetry, or they can use scanners. It really just depends on their data capacity, to be honest, what they're doing with all the data they're capturing. And then of course the functionality, right? A photogrammetry set is going to be very different in functionality than a LiDAR set. Tim?
Definitely. I mean, so I think the biggest thing is, remember that new quadcopters are basically little planes. And so you can get even more on that. I've seen some of our customers are sending through that are LiDAR scans with photogrammetry attached all at the same time. But then there is another way of doing it that's just a bunch easier, is either having two drones, or you do LiDAR. You can do plain LiDAR, which is actually not super expensive. You can run flights back and forth. You find a crop duster guy, and you put a LiDAR on the bottom, like a laser. That's how you do it. If you go to want to do a Mayan temple or something like that, and then you can send a drone through to get these scans, or you could do just LiDAR, sky LiDAR, which is white and black, and then add on top of that photos from the ground. And then you combine that all together and you get some really amazing things. I really think one of the biggest things that you want to remember in this situation is that it's a little bit more interplay. There's a little bit more, did we get that area? Because it's not just one scan, it's multiple scans. Although LiDAR on its own really does a really good job, as long as you're not concerned with having color that's in there, colored point clouds with RGBD depth, using something like a real sense camera or something like that, does combine it all together, and then you end up getting like a bag file or something like that out of it, and then you get some really good stuff. Obviously the quality is limited because it is a technology that is more consumer grade than professional grade, and things like that. But there's a lot of really good answers here, and there's a lot of even better answers that are coming, especially as we're getting better now with things like view illusion, view synthesis, as it's actually termed, and then different things like being able to combine LiDAR better with photogrammetry. I mean, it's been around for a long time that we're doing this, but really the ability for machine learning algorithms to centroid out the two assets has gotten a lot better. So you don't need a manual back and forth to kind of get it going. So yeah, that's where I would come from on this.
Yeah, as Tim mentioned, these sort of examples are the standalone scanning examples and the standalone photogrammetry examples, but the reality is there is a lot of application and function and just amplification of the technologies when you can combine them, and we'll talk about a couple of those going forward as well. So obviously, we're talking, your asset build out, your scene build out, your character rigging. Again, very similar use cases, but ultimately, what you're doing is you're creating even more depth, even more information. You're getting a lot more data to deal with, and overall, it depends. Do you have the money and the equipment to create scans, or do you have the money and the equipment to create photogrammetry arrays? Are you focusing on capturing in a studio? Are you focusing on capturing outdoors? So there's a lot of different ways to sort of slice this and dice this and figure out the technology that actually serves best to the purpose that you're working toward.
Yeah, definitely. I mean, in each and every one of these instances, like we talked about, there are good answers. Are there great answers yet in this world? Not without a lot of manual intervention, which is, where we're trying to work right now to change. Machine learning algorithms feeding back into LiDAR to go ahead and increase the amount of points that they're capable of, is really going to help out, because LiDAR with really high precision is actually extremely slow. So being able to go ahead and fill in those places and provide still a smooth surface that gives sharp edges, and adding that with photogrammetry and doing the same exact concept where we're filling in the places between the photos with few synthesis really is going to give something great. Something that we discussed and touched on a little bit was using depth data, so RGBD, and we're talking about things like unstructured light, and then of course, really light, structured light styles, things like stuff from occipital, the structure sensor, which is a structured light algorithm, and then of course, unstructured light, which is stuff like time of flight, which comes back from Microsoft style captures, and then of course real sense is a little column A, little column B, depends on which generation you play with. So right now it's kind of we're kind of at a arms race, and it doesn't appear that anyone's really kind of coming out the victor, nor is anyone providing solutions that replace what should be, and really you can get some amazing results out of photogrammetry that aren't even possible with the combination of photogrammetry and scan. But it's, do you have the time, kind of thing, like trying to literally get somebody going up on scaffolding to go ahead and capture that castle in the middle, that would be quite entertaining, let alone months worth of work. So there's always a trade-off. So yeah.
The other minor distinction here is that scanning is more effective, and it does mention this if you read through the slide. It mentions this, thin and ornate objects, intricate wardrobe pieces, those types of things. Photogrammetry is all about coverage. If you have a million photos of something, it will be great. If you missed a spot, then you're, and that's where a lot of this sort of recreation of data comes in. But ultimately, scanning is a better use case for highly elaborate objects, wardrobe, people, and places as well, because there's a lot of intricate detail in, a castle versus a skyscraper. So, and last but not least, volumetric video. So the goal with volumetric video is really to capture a person or object in motion. So the incredibly functional part of volumetric video is capturing human faces. So we have macro and micro expressions. We have flushing that is incredibly highly easily for us to detect as humans, and trying to recreate that via other alternatives is really challenging. And so that's, when you get to that point where you're watching that movie and that CG character is like grossing you out or freaking you out and kind of weirded out by it, uncanny valley, right? That's kind of inevitable. And the massive amount of, VFX and humanoid and virtual human, things that are happening in the world, not in just movies anymore, across the spectrum of media, we're really seeing there's a great opportunity for volumetric video to take that place and really help bring that humanistic side to characters. We also think that it's wonderful to drive facial animation, whether you're overlaying with an animated character or whether you're animating it for some other use case. It's wonderful. And we think that this is really the future of capture. This is where it's all going to angle toward. And what do you have to add, Tim?
I have lots of things to add, as is always. I think the biggest thing, and the reason why Alex is talking about, facial rigs are a lot easier to control in both instances. Having a large rig like this, where we're showcasing, this is 120 cameras, there are 26 computers that are involved. The technological need is extremely high. And the reason why we have so many computers on this one had nothing to do with computational capability, has everything to do with getting the data back. So the amount of data that needs to transform, out of that many cameras is so high. You have to think, we do for 1920 by 1080 on all of those cameras over 100 gigs per minute. So, if you go up higher, if you talk about 4K, 8K, you could easily burn through, and I've gotten 10-second sequences that were 2 terabytes from very large camera arrays. It's just, it's insane. And so volumetric video, if you reduce that down to like head, and we talk about we're reducing this down to the idea of adding motion capture and things like that, you can go back to a lot of really good technologies that are out there, until the time that technology does catch up with it. Volumetric video has a lot of really wonderful use cases as well. If you are trying to get gross movements, background movements, if you have the space, the processing, the time, we've proved that you can save a whole bunch of money by doing it in volumetric video. The biggest thing is it's that price to entry. So, as some of the discussions that we had prior to actually starting this speech, doing 360 is a higher quality, but the cost is exponential. And doing volumetric, it's the same. Photogrammetry can be a small, DSLR rig, while volumetric video is a very large DSLR rig that needs to have massive amount of precision that's on it. Or you can use, in this specific case, things like webcams or anything else in between that. So I love the technology. I think it's great. And I definitely think that it is the future of video. It is fully three-dimensional. And technology right now is moving in leaps and bounds to meet the demand that is requested of what volumetric video can provide, because two-dimensional video provides so little information. Let's really be honest about that. And if we kick off to the next slide, you can definitely see that it's not just about actors and cameras and things like that. It provides the ability for the world to be you and you to be in the world and everything to match all together. And so I really believe that as we continue feeding this technology, as you look at the character over on the left, he's as real gets. And that will continue to happen. And we will continue to make those things. So yeah.
Yeah, so our technology itself, on the volumetric video side, does not require a green screen. And the goal there is, again, to just drop that bar. You don't have to have an entire green screen studio available to you to create volumetric video. You don't. And we have tested everything from your webcam rigs all the way up through very high-end rigs with DSLRs and you name it. We've done all kinds of processing for a wide variety of clients from their rigs. And we don't often know even what the rig is in and of itself, how many cameras it has necessarily. Well, there's some data, right, that gives us the some of the basic information. But the reality here is that, if you have capture capability, then there's no reason that you can't have the ability to extend it to volumetric video if you're not already doing it. It's great for digital doubles, facial animation, of course. And as we mentioned earlier with the combination of technologies, and what Tim was talking about just previously, was that combination of the facial rig, so you can actually capture a bust and a face and get that realism from the human, and then you combine that with photogrammetry. You do photogrammetric capture of the body in an A pose or a T pose, then you can rig that. Then you can actually create, a mocap process with that. I mean, there are a million things that you can do with that. And not only does that minimize your physical footprint for the rig, space that you need, but also minimizes your digital footprint, because the asset can be significantly smaller, because nothing that volumetric video is a hog. It just is. And so there's a lot of functionality within the shoot itself where you can, there's opportunities as well. So drone matching without GPS, we've actually done that with a couple of clients. Match moving, crane shots, group and remote location shots, stunt shots, all of these things can be improved safety-wise, time-wise, and ultimately it gives back a lot of that creative freedom that the director has, because you have a full 3D person or object that you can manipulate the scene around. Or you can manipulate them in the scene, like vice versa, and it's going to minimize or really just get rid of reshoots massively. So there's a lot of wonderful ways to execute volumetric video into content creation for movies, for games, for you name it, really anything. So
Definitely. I think one of the things, so, to give you an example, one movie that I worked on specifically had a main actor. And that main actor, we did a full digital double on, and the full digital double was originally slated for 1.5 minutes and had a whole bunch of different things that they wanted to do with it. So it was a full digital double, hands, fingers, face, full facts, like you name it, all the way across the board. And an asset like that costs multiple millions of dollars, not just capture, process, putting it together. And then it was pushed down to about 15 seconds, and it was something that was literally just because it was a dangerous capture and they wanted to go ahead and do a switch out between the main actor and the stunt double. They end up just using the body pose because they're like, oh, we have this digital double and we have to do something with it. And so then they end up putting it in. When if you had just done it in volumetric video, you really could have gone ahead and gotten it through in under $30,000 versus multiple millions of dollars. It just shows that there is a new style of technology, and that there are really good use cases for it.
Hi.
Hi, hi everyone. Wait. Okay. How are you guys?
We are well. How are you?
Good.
Yeah, I'm good. Great presentation about the 4D and also 5G presentation earlier. This is personally for me, I learned so much a lot about this, and this is great presentation from you, and I think everyone love it. And we have other viewer here on chat right now, seeing with us, and yeah. Maybe we can jump right to the question. Some question
Sure.
that people have so many questions about your presentation earlier, and maybe some from me. This is a quite great presentation also from you. So earlier that you said that there's 9 process in the visual effects that in building the visual effects early on. Then that you say that some of the step already and in AI processing. Computing to build a scene and also asset and also character aging, something like that. How how advanced that AI compute right now on that process? Can you share with us about it?
Sure. It really depends on which section that you're talking about. If you're talking about character rigging, it's lagging a little bit. It's good at the initial setup, but some of the secondary facial features, being able to get that perfect eyebrow and things like that. There's been a lot of work recently, especially if you look into what Digital Domain has done to be able to go ahead and make that. But as far as all the rest of the features out there, machine learning lighting, secondary maps, things like that, there's a lot more ground that's been covered in that world. Tell you the truth, I mean, at this time, even then, I would say we're in the infancy. And I think, even in the world of machine learning, we're in its infancy at that point. Every day there's a new algorithm that's either faster or better, depending on which direction we go. The idea of adversarial networks has not been around for that long, and that is what we leverage a lot of, being able to fill in that point between, well, this is what a person should be making, and then this is what an artist interpretation, and then this is the realism, and how do we blend all of those ideas together. And that's something that is advancing on a regular basis. So extremely advanced as far as the levels of technology, but I mean, I still think even then it's child's play compared to what we'll have in 5 years.
Yeah, we have miles to go, and within our pipeline specifically, we use AI and machine learning in a couple of different ways. We use it in one way to actually increase the speed of our processing by allocating compute resources appropriately and efficiently. And then we also use it within each individual process for imagery fidelity itself. So those are like completely wildly different applications in and of themselves. And there are a lot more ways that we could add in as we grow our product and as others grow their products.
Yeah, that's great to hear about it. And also, there's some question here that about for the last 5 or 10 years, how the growth of this technology means to the industry, and also how do you see it in next 5 years on this technology impact the industry?
Yeah, I mean, for us specifically, our view is definitely that our product will be integral in really dropping that bar and making these processing capabilities more widely accessible. I think that over the last 5 years, there's been a lot of movement. Volumetric video itself has come a long way. We are now moving out of the studio model, the dedicated studio model, and there are a lot of really interesting and cool things. We're seeing more and more widespread applications of scan data into virtual production. And I think virtual production is really going to change the face of XR. It's going to change the face of movies and entertainment as we know it, and many other ripples.
So to give you an idea, I think, and people are afraid, is this going to take jobs? In the beginning, probably. In the beginning, probably. And that same thing happened when we went full digital. Skills change, skills move, and things go along. But I mean, the VFX industry, other than how COVID has hurt it, has been stronger than it ever was. And that all really does come down to the need of manpower. And that will change and augment and move along as we have always done. Bigger movies require bigger budgets, require more people. And that will never change. There's always this boom and bust kind of situation. And we're coming into a bust based on the assistance of machine learning algorithms to be able to create some of the lower level work.
Yeah, I think that's interesting to hear also because you said earlier about head replacement also in your presentation. It's still in research and development from you said before, but this is gonna big change for the gaming movie industry also to have this kind of technology. Maybe the actor doesn't have much more scene to have, so they can just replace their head and doing cap motion to replace everything, something like that. And how do you see that this head replacement within the next or couple of years will be more implemented in this industry?
I don't see why not. I mean, where we're sitting at right now, since even we recorded that talk, we finalized versions of it, so you can go onto our YouTube and to our Sketchfab as well. You can actually see implementations of the technology. What I really see is happening will be the kitsch. That's what always happens in entertainment and in marketing, just in general. The first thing is, just like when VR came out, it was all shiny stuff. Was there any real substance to it? No. You'll start seeing, Frank Sinatra come back to life. You're gonna, get Doris Day and on all these famous people to come back, and then they'll be driven through the multi-million points that volumetric video can provide, and then we're gonna see stunt doubles and body doubles replacing actors on main stages, and they'll do their main captures. And then eventually there'll be a tipping point. It's that same thing. Actors have gone back and forth as well. I mean, if we go back to Stanley Kubrick, he literally still has the Guinness Book of World Records for the most number of takes. So it is a dance and it's a flow, And then if we look at movies that have come out recently where we're actually de-aging actors, it's not going to go anywhere. We're just going to find shinier and cooler new ways to do it. In the beginning, it's going to be glitz and glitter, and that's what the industry does really well. And then we'll find real good use cases for it. So,
yeah, that's definitely true. And the other thing really is like giving back that creative control. A huge part of the value here is being able to do those dailies, to really see what's going on set in live, time, to understand, how the decisions you're making now for, your directing, your backgrounds, your prop sets, actors, all of those things, whether they're being implemented into film or whether they're being implemented into XR are really important to understand clearly. And as the immersive, becomes more ubiquitous and becomes more accessible, it makes it easier to do that and have that creative control.
Yeah, I think that's great insight also for the industry at this time. And also, this is more technically side of this work that you guys do. What do you think that what suggestion that you give to the some of the beginner that newcomer to this technology, what they should do, start to learn, where they start to learn, and also what kind of the things that they need to avoid at the beginning to make things not go wrong, something like that.
You want to do it? You want to do it?
Go for it.
I can do it. Okay. So I'm, obviously I do speak from the technical side, but it really depends on what angle you want to go at. For me, I came from the heaviest of tech. My tools. I come from, pipeline automation, tools generation, creation, like being able to see what happened on the back end as to its generation. But it takes a heart. I'm not trying to replace artists. I'm trying to make their work less burdened. Most of the things that are done inside of the industry are just, it's akin to somebody who literally sat there and cut film. There were people that was their entire job. Walt Disney had cell washers. They literally sat there with acetate and they washed off cells. We don't need to do that anymore. And we're watching another iteration of that. So what I would say when we're talking about newcomers, people that are going into this and people who are interested in creating a real change for the industry is, look at the stupid work. Look at the stuff that if you're replaced by a machine learning algorithm that's doing that, maybe you should find a new skill. Those kind of things. Those are important to make it to where we allow the best and the most talented individuals to make our movie shine even brighter.
The thing that I'll add to that is there is no shortage of opportunity to contribute to this space, whether you're a developer, whether you're a marketer, whether you're an artist. And I think that sometimes, we think of tech and we think of the technical portions of it, which are very key. But I am not a technical person. I'm not a coder. I am a business person and I have my hands into everything in our business that we do. And I have a very deep technical understanding, but I'm not a technical executor. So I think, fundamentally there are tools out there, your Unities, your Unreals of the world, foundational platforms that you should understand how those are being leveraged, content creation tools that are, widely available. There are student licenses. There are all kinds of interesting ways to interact with these things. Really understand and learn those basics and come to it with an open mind.
Yeah, I think that's true that open-minded for developer, for any engineer should have, right? All right. I think we have the time up right here. So thank you for your presentation and also for your Q&A session. This is so great for everyone to learn, also get insight from you. Thank you very much, and see you later.
Thanks.
Bye.
Bye.
Bye.